Hi viewers, good afternoon. This is Chandana, Assistant Professor, Mlritm. Like our previous lectures, we will learn how critical thinking will happen in the next scenarios. In the today's lecture, we will see about how prime numbers will be printed till a given limit. As such, we have seen in the previous lecture that we have given an input as one number and we were just telling whether it is prime or not. In the current example, we will be printing prime numbers till the given limit. That means I give a limit saying some 100 or 200 or 300 and prime numbers should be printed till the given limit. So as like with our previous session, these are the prime numbers which we have. These are all the prime numbers and this is not a prime number. Let's recap what is prime number. That is a number which is divisible by 1 and itself, and it should not be divisible by any other number. So we will always depend on that the count should be equal to 2. That means count lesser than 2 or greater than 2 is not considered to be a prime number. Now in this scenario, I will be giving a limit. So as per the previous sessions, in a critical thinking part, we have to look into three parts, that is input, output and the logic. In our question, we will be giving one value that may be from keyboard as an input or directly as an initialization. And I am marking it to be as limit. That means identifier name I have given to be as limit. Behalf of this, I can even give it as some letter N, K, A, something else also. But for better understanding, I have given to be as limit. And the outputs to be printed are 2, 3, so on like this, all the prime numbers. Let's see with the logic. Now, if I give a single number, we have done some modulo division. Then we have checked with the remainder. And if the remainder is 0, then we were taking that, increasing our count. And later on checking that if the count is equal to 2, we will be printing it as prime number. Now, it's a slight different from the previous. It is incremented with the previous. See this scenario. This n is my limit, okay? This n is my limit. Let us think that limit is some 20. So, starting from 0, 1, 2, 3, so on to 20, every digit should be checked whether it is divisible by 1 and itself. Let us don't take these two conditions because 0 is neither prime, 1 is neither prime. So how to write code for 0 and 1 which is neither prime also we'll look into. Let's start from 2. So digit 2 should be taken. Again come here, check this digit 2 whether it is divisible by 1 and again whether it is divisible by 2. Okay, starting from 1 to n, that is same number. So if the remainder is 0 here, remainder is 0 here, then we will be saying that count is 2 and as the count is 2, we'll say it as a prime number. Same scenario should be happening for every digit here. Okay. Here also there should be an increment from 1 to n. Here also there should be an increment of numbers. So looking to both the sides, I need a for loop here which will just be applicable for division purpose, that is this value. Okay. Then here to the left side, I also need a for loop here where it will change the digit for the checking. That is the left part. We will see the code for it. My I is number 2. My j is starting from 1 and 2. Okay. So j should also rotate from 1 to n and I should also rotate from 1 to limit. So the end for I will be limit, end for j will be what? End for j will be depending upon I. So end for j will be I. And once this happens, my count gets incremented. This is what we know already earlier. Okay, this part is known. Now see here, I am just talking about the j value. J should start from 1 to I. Okay, less than or equal to, because I even should check with given number. Then this is the set loop. Here for this for loop, I am only talking about I situation. That is, this J situation. That is, J will be rotating from one scenario to I limit. If I value is, for example, 4, then my J will be rotating from 1, 2, 3, 4. Okay, because this I is 4, your J value will start from 1 to J value is equal to 4. Now what should I do when I wanted to increase this I value? I have to write another for loop. This is the another for loop where I am starting from I is equal to 0, I is less than n, and I plus plus. Now see, when I is equal to 0, as in the first case we have spoke that 1 and 0 are not prime numbers. So 1 and 0 are not prime numbers means I have to start it from 2. Okay. So this would not be existing and 2 would be the starting value of I. That means number 2, from number 2 I will be going on checking with each digit. Now the point you have to remember is, when I start for loop from here, okay, let us think my I value is 2, okay, 2 is less than n, yes, condition got satisfied. Once condition satisfied, the cursor goes into the for loop, this for loop, then my J will become 1, okay. J is less than I, yes, J is less than I. As the condition got satisfied, it goes into the J loop. Then if I percentile J, that means 2 percentile I is equal to 0, count gets incremented. As count gets incremented, now count will become 2. Then what happens? Then the inner for loop gets incremented. That means J plus plus. This action happens. So your I is as it is 2 only, but your J became 2 now. 2 is less than or equal to I, condition satisfied. When condition satisfied, J for loop gets initiated and your I percentile J will happen. What is your I percentile J now? 2 percentile 2, which is anyway equal to 0. So your count becomes 2 again. Okay. Next what happens? Again J gets incremented. Now your new J value is 3, right? And your existing I value is as it is. I is not getting changed. Only J is getting changed. So J becomes 3. J less than or equal to I. That means 3 less than or equal to 2. No, condition did not satisfy. So your cursor will not move into this for loop. Okay. Once inner for loop gets false, your above for loop comes into picture. Okay. The above for loop, when it comes into picture, now your I gets incremented. Okay. But before your I gets incremented, what I should do? Whether this existing I value is a prime or not should be checked. Okay. Once it is checked, that means count is equal to 2. I have to print my that number is already prime. Okay. Then what I will be doing? I will change my I value to be 3 because I plus plus has become into picture. That means 3 less than n. What is n now? N is my limit. My limit of 100 or 20 or 10, whatever we have given. So 3 is less than n. Yes, condition satisfied. Now your 3 value comes into picture and your for loop again gets activated. Now your I value has changed to 3 and J value starts from again 1. Okay, J is equal to 1. So 3 percentile 1, which is equal to 0. Then J gets incremented as usual. Inner for loop gets incremented. Your J becomes 2. 2 is less than I. Your new I is 3. So 3 percentile 2. Okay, here also it is 1. Okay. Right? Your remainder is 1. So your count will not get increment. Next, J becomes 3. 3 percentile 3. Your condition also got satisfied and 3 percentile 3. your remainder is 0. So your count gets incremented. As of now, there are 2 zeros, so count will anyway become 2. Then your j gets incremented, that means j will become 4. 4 is less than or equal to I value. New I value is 3, this became 4. So your condition did not satisfy. When condition not satisfied, this loop will not be getting executed. But although this loop is not getting executed, after this loop immediately we have to print that 3 is a prime number. So because we completed here, we have to print 3 is a prime number. We'll see that code also. But in this, what is the inner sense we have understood? Every new number when I take, that means every time when I increment I, okay, I have to also check that whether my count has been starting from the first. If no, what happens? In the first case with 2, when I value is 2, my count was 2. Okay, satisfied. And I have printed my prime number, fine. If I don't make it a 0, if I don't make count a 0, when I is 3, my count gets incremented from the existing 2. So it becomes C is equal to 3, 4, 5, 6, 7, 8, where it will tell that count is some 6 or 7 or 8, and it will print that 3 is not a prime, but actually 3 is a prime. That means every new number that when I take, that means every I gets incremented, count should automatically change to 0. That means it should start from 0 and calculate. So we will write count is equal to 0 here. If you write it above in the starting of your program, the 0 will be initiated only once. Now what I am doing, I am writing in the loop, in the for loop. That means when I change my I value, automatically my count also reinitiates itself to 0, settles itself to be initialized as 0, and then goes on doing the same procedure. Now see here, as I told, I will be starting from 2. Your count is initialized here to be 0, so that it rotates for every I value. And this is the closed loop of if, this is the closed loop of for, that is inner for loop. Before changing my value to be I have told that whether count is equal to 0, print that value. Okay. And then when I increment, same procedure happens repeatedly. This is your final program where I have taken n value as the limit. This is n value limit. I even did not do the initialization here because I am doing it here, and I mandate that I have to do it here itself. So I did not do my initialization above. This is the output once I executed. See, enter the value 20. I have entered my limit to be 20. It is printing 2, 3, 5, 7, whatever are values within 20. What are the prime numbers? Now you may get a doubt. Okay, can I print saying that 4 is not a prime, then 6 is not a prime, then some in between numbers are not primes? Can I do that? Let's see the scenario question. But before that, we have skipped some 2 things. That is, I is equal to 0. That means first number when it is 0 or 1, they are not prime. But I did not write in my code anywhere that print those 2 are not prime numbers. Now I have extended my code where you see in the when I take, if I wanted to write I to be is equal to 0, I have to write internally that if I is 0 or, this is logical or, I is equal to 1, okay, then print they are not a prime. In these 2 cases, automatically the system will print it is not a prime. And when I becomes 2, from there on your for loop part executes, that is else part gets executed. See, when I do the previous question which I have given, previous logic, I have given my n value to be 10. It has printed 0 is not a prime, 1 is not a prime, because I wrote this part here. That is I double equal to 0 or I double equal to 1, it should be printed as not prime, and later on 2 is a prime, 3 is a prime, every line it is printing. But still we have one more doubt, one more thought, that In intermediate here, I don't have a number. Here I have 4. Whether it will tell 4 is not a prime or whether it will tell 6 is not a prime, can I do that? Let's take now the exact scenario based question. Let's read the question. A professor wants to divide students into 2 sections, okay, in which he wants the roll numbers which are prime to be moved to A section and roll numbers which are not prime to be moved to B section. Help the professor, and these are the test cases given. So as per the test case, when you are doing scenario based questions, as I told in the previous lecture, your expected output should be kept in sense, okay. What is been exactly expecting from this is your test case. Now, if I give input as 1, it should print that 0 is not a prime and it moves to which section as per this scenario. And 1 is not a prime and it should move to which section, okay. If I give 2, it has to give like this. If I give 5, it has to give like this. So every number, it will be telling whether it is section A or section B, also telling that it is prime or not a prime. As per our previous code, let's see where all we have to do the changes to achieve this type of test case. Just there are minor changes. I is equal to 0, I double equal to 1. If both are the cases, it should automatically tell not a prime, that we have already written, but I have extended slight that it is section B, right? Then when count is equal to 2, in your previous code, we just wrote it is prime, that's all. But now count is equal to 2 is a prime and also section A, else count is not, that means when this case is not been satisfied, count is not equal to 2, then it should print it is not a prime number in section B. So every digit it will tell either it is section A or section B. My test case was 3 different test cases. I am checking for the 5th one. That means input I am giving 5, which will, so that I should get this expected output as my output. See the expected output and the actual output. I have given my n value to be 5. It's clearly printing 0 is not a prime, section B. 1 is not a prime. 2 is prime, section A. 3 is prime, section A. 4 is not a prime, section B. So this division, exactly these outputs you should get when you solve your scenario based questions. And these are the references I have taken. Students, we have completed 2 topics, that is given number, it should be a prime or not. I give a limit, I should print all the numbers in between 1 and the given number, whether they are prime or not. In this scenario, we have also seen that what are not prime also will be printed, what are prime also will be printed. Your 0 and 1 cases also will be completed. Thank you all.